State the amplitude, period, phase shift, and vertical shift. So we've got a lot going on here. So let's break down each of them. This is just a transformation. Think back, we've been doing transformations all year. So this number in the front, what does that do? This stuff in the inside or on the interior of the function, for starters, we need to break this up or factor out that 5. So if we factored out the 5, it would be x minus, be careful, factoring out a 5, when I multiply it back, it better be pi. So it's going to be pi over 5. And again, double check, 5 times negative pi over 5. Yeah, it would be negative pi. So we're good. So let's break that up first, and let's look at this 3. The 3 has to do with the amplitude. So my amplitude, 3, done. Okay, the period is taking b, or I should say 2 pi over b. b is located right here. This number that we factored out. So if I did 2 pi over 5, that would give me the period. So 2 pi over 5. So I just used the a and the b so far. Amplitude is this number out in front. And the b term, or how I find the period, 2 pi over b, is this number that I factored out, that 5. Okay, midline. I did not shift vertically at all. So there's no number out here that I added or subtracted. So my midline is going to stay on the x-axis. So y would equal 0. Okay. My frequency is the reciprocal of my period. So here's the period, 2 pi over 5. So my frequency would be 5 halves, and pi would be on the denominator. So take the whole thing and find the reciprocal of it. Maximum value. The amplitude is from the midline straight up, straight down. So if my midline is at 0, or on the x-axis, that means I'm going up 3 and down 3. So my maximum value would be 3, my minimum value would be negative 3. Okay, and then we need to worry about our shifting, our left and right shift. I'm going to go through, I'm going to get some, here it is, left and right shift has to do with this number right there. I have pi over 5, but it is negative. So you would think it would go left, but it actually goes right. Right, pi over 5. For 27, I'm going to start the same spot. Start with amplitude. I have an amplitude of 1/2. That a term. The period, which is covered up. There we go. The period is located here, but let me write this really quickly. I have this b term. So a is 1/2, b is 4. So I'm going to find my period by saying 2 pi over b, which in this case is 4. So my period is pi over 2, or 1/2 pi. So my period, pi over 2, which means my frequency would be 2 over pi. Again, these are reciprocals of each other. So if you know one, you should know the other. The midline. The midline is where things change on this one, because the previous problem didn't have it, but this does have a vertical shift. So it is shifting downward too. So my term, or my midline term, is no longer y equals 0. It's going to be y equals negative 2. Okay, I'm going to draw this out so it makes sense, hopefully a little bit more. So going down 2, this is the middle of my graph. My amplitude is 1/2. So from here, I'm going to go up 1/2 and down 1/2. I know it's really hard to tell on this graph. So if I went up 1/2, which is not drawn to scale, I would be at negative 1.5, or negative 1/2. If I went down 1/2, I would be at negative 2.5. So these two measurements are the max and min values. So the maximum value, which is still negative, it's going to be negative 1.5. The minimum value goes below that midline, so it's going to be negative 2.5. And in this case, the phase shift, I look at if it went right or left, and it did not have anything in here that I needed to factor out or add or subtract from it. So my phase shift does not exist or not applicable.